Hello everyone, I'm Dr. Sri Banerjee, core faculty for the College of Health Sciences and Public Policy, Walden University, with a joint faculty appointment at Ross University School of Medicine. And in this video, I'll be going over a bit more about climate change. So here, what I wanted to show you is that similar to what I said about methane in a different audio or video, similarly, carbon dioxide, even though way more in concentration, is in the atmosphere. So it's important to understand carbon dioxide and the effect of carbon dioxide in all of the atmosphere. So what happens is, of course, when the sun hits the rays hit actually into the carbon dioxide, then it causes to be not only in the atmosphere, but actually dissolves into the ocean. This causes, of course, the pH to drop. Carbonic acid, it fizzes like Coke. So then you have the pH actually lower, and this process is called ocean acidification. So get this, the temperature has increased of the ocean, and so that is causing a fizz-like effect, an increase in some of that heat from carbon dioxide, increase the heat, and then you see changes in the snails, changes in some of the organisms that live under the ocean, even with a slight increase in the ocean temperatures. So the lesson here is carbon dioxide is bad for the environment, and in effect bad for us. So any carbon dioxide emissions have to be considered. So I'm just going to go through some of these, basically showing what I just explained to you in various figures. So based on analysis from NOAA's Global Monitoring Lab, the lab average atmospheric carbon dioxide was 414.72 parts per million in 2021, setting a new record high, despite the continued economic drag from COVID. In fact, the jump of 2.58 parts per million over 2021 country amounts tied for fifth highest annual increase in NOAA's 63-year record. And this shows this how 414.72 then jumped to higher, and so this trend, the slope of this trend is actually becoming more sharp, and that's not a good sign. So we have to take these actions. Each year, human activities release more carbon dioxide into the atmosphere than natural processes can remove. So the global average carbon dioxide set a new, like I said, I told you, a new record high in 2021, 414.72 parts per million, and that was the average. That was the common, and that was the value. Despite the continued economic drag, fifth largest one-year increase. The annual rate of increase, of course, atmospheric carbon dioxide over the last 60 years is about 100 times faster than previous natural increases, such as those from the last ice age to 17,000 years ago. So 0.1 unit, 30% increase in acidity. And then you have atmospheric carbon dioxide parts per million. So atmospheric carbon dioxide amounts and the annual emissions. So here, what you have here, the gray line actually represents human emissions. So the gray line is human emissions, and then the blue line is just total atmospheric carbon dioxide. This one's worth looking into again. So let's get into some of the writing here. Carbon dioxide matters. Carbon dioxide is Earth's most important greenhouse gases. A gas that absorbs and radiates heat. So oxygen and nitrogen are abundantly available within the Earth's surface, Earth's atmosphere. But oxygen and nitrogen, they don't actually absorb heat like this. So Earth's natural greenhouse effect would be too weak to keep the average global surface temperature above freezing. So here's the temperature, the ocean acidification effect. There's a clear shell, but now the shell is cloudy. And there's so many different consequences of that. So one of the interesting things that takes place, the warm episodes, interglacials, began with a small increase in incoming sunlight in the northern hemisphere. This was due to the variations in Earth's orbit around the sun and its axis of rotation. For more details, the Milankovitch cycles and ice age section of our climate change incoming sunlight article will provide more information, so if you wanted to look over that. So based on the air bubbles trapped in mile-thick ice cores and other paleoclimate evidence, we know that during the ice age cycles of the past million years or so, atmospheric carbon dioxide never exceeded 300 parts per million. So you see the changes come about through the Industrial Revolution, and carbon dioxide over 800,000 years was not as much as what is here right now. So you have multiple different types of SSPI, and that is just different types of so this one's somewhat of a complex figure to determine, but once you kind of get the hang of it, you'll be able to understand it better. So just to give you a full view of this figure right here, this is very high very high emissions, and this is very low emissions. So the idea is that very high emissions, as we see in the deep red, that is for SSP 5 to 8.5. So the SSP 5 is for socioeconomic status. Depending on, so the idea here is that depending on the socioeconomic status, there's going to be very high emissions when there's low socioeconomic status. But then the high socioeconomic status actually went down. Very low emissions for them. And also 4.5, kind of middle is fine too. But then the top two are the bottom, kind of, they're going down too, but still very high. And then this is kind of a future, these are all future predictions, by the way. These are future predictions based on currently what's going on in a different model. So that's the gist of what is being described here. Lower socioeconomic status, lower path, so the pathways, then higher the carbon dioxide emission. So a shared socioeconomic pathway is an internally consistent set of emissions assumptions about future population growth, global and regional economic activity, and technological advances. So this is extrapolation based on that. So there's more on carbon dioxide. This is a good fact sheet to have in different contexts. And so this is from NASA.